In Chapter 23, we're going to be dealing with our circular functions and trig stuff and how to differentiate with those things. So we're going to start off with an example involving the area of a triangle. Find the rate of change. Rate of change should clue you into we need the derivative. In the area of ABC, as angle A changes when A is 60. So what we're looking at here is we need a formula for area. And we have a formula for area in that it's 1/2 times 12 times 10 sine of theta. So our area function is 60 times sine of theta. Given that we know the angle and the two sides adjacent. So we can find dk d theta. This would be 60 cosine theta. And plugging in 60 degrees or pi over 3 radians, we get that this is 30 square centimeters per radian. And this formula, this idea of differentiating with respect to an angle, it only works for radians. Now we're differentiating a cotangent function. It's actually a composition of functions. Hopefully you're envisioning that we're going to need to use the chain rule a couple of times. Square root is the same as the 1/2 power, so 1/2 cotangent theta over 2 to the negative 1/2 times the derivative of cotangent. And that's in your formula packet. Well, we get negative cosecant squared theta over 2, and chain rule one more time, times 1/2. This can be cleaned up just a little bit into one fraction that's over 4, because we've got 1/2 and 1/2. The negative 1/2 power causes a square root cotangent theta over 2 on the bottom. And in the numerator we have negative cosecant squared theta over 2. So here is dy d theta. Last example I want to go through is how to find the derivative of an inverse trig function. How do we take the derivative of arc sine x? If we think of this as a function, y equals arc sine x, that's equivalent to x equals sine of y. And hey, now here's something we can differentiate. I'm going to take the derivative with respect to x of this. So we get 1 equals cosine y. Then we have to use implicit differentiation, dy dx. We can do simple solving. Dy dx is 1 over cosine y. But with implicit differentiation, we don't want to leave a y in this. We want to get rid of that. And the only way we're going to be able to get rid of the y and replace it with x is if I involve sine of y somehow. And we can accomplish that with the Pythagorean identity. And since sine of y is x, here's our derivative. The derivative of arc sine is 1 over square root 1 minus x squared.